Hey guys, welcome back. We're here at our project. And I gotta tell you, it is a hot summer day. It really creeped up on us fast. It's hot already. We weren't ready for it. Everybody's been out in this blazing heat all day, so a little bit tired. I'm gonna wear my sunglasses. I apologize for that in advance, but I just can't take it without them. It's too bright, it's too sunny, it's too hot. But we have a lot going on. If you look behind me, you can see the foundation is being formed. That is the basement you can see there. The footer has gone in and now they're starting to form the stem wall or the walls of the basement. And they're starting to put in their rebar verticals and horizontals now. So come along with us, we'll check it out and take a look around. So for now, the walls are just started. The forms are just started. They're not all the way secure yet. So they have a few turnbuckles here that are starting to true up the walls. They'll add more wailers. That's the horizontal 2x4s that you see. They'll add those as they go along and it'll stiffen up that wall so they don't have any blowouts or messes or any issues after they pour. So this area down below that's already been poured, this is concrete, that is the footer itself. So all of that is to the geotechnical engineer's specification. There is a suggested bearing capacity in there, and then the structural engineer comes in and designs the foundation around those parameters. So what you see there that's been poured and stripped and now has the stem wall forms attached to that, that is the footer. So that's what makes contact with the ground. On top of that is the stem wall. Let's go around a little bit closer. All right, so now we're peering into the basement of the house. This will be a walkout, so we will have doors here that will walk out into the backyard located behind you. That as we look in, you can see more of how the structure works. So again, this area that's already poured, that is the footer. Sticking out of the footer are the dowels. This is one of those vertical dowels that goes inside the footer. You'll notice that it makes a J shape. If you come over here and check this out. So each one of those dowels goes down inside the footer and then ties into the horizontal bar that's located inside this footer. That ties that structure together and provides both the shear and the tension for this wall connection behind us. Each one of those is located on 16-inch centers and goes into the structure of the wall. Come on in, we'll take a look even closer inside. So now you're stepping inside the house. This will all be filled in with gravel and actually get in-floor heat. So eventually we'll take a look at the heating system, tubing and all that and how that's designed. Our floor height, our slab height inside of this will be 5 inches over the top of this footer level right here. You can see the vertical bar, number 5 bar, that's 16 inches on center going through the structure. And then our horizontal bars, which is a number 4 bar, 16-inch center. That makes our structure for the wall. These guys will place this all the way around. They'll add another course of forms over the top of this. Place this all the way around, and then they'll start to close it up by putting the forms on the other side or this side, closing that in before they pour. Something really interesting also to check out is you'll notice we have these voids. So this is a box void underneath the footer here. That box void, again, they all goes back to the bearing capacity specified by the geotechnical engineer and then the structural engineer working around that. This box void is actually to reduce the amount of weight that's being placed on the soil and to work just to how the loads work inside the house where we have point loads and all that coming down. If there's not enough load there, then they'll put a box void in, distribute that load out so that we have more load on either side of it. It's not so much that we're getting too much, we don't have enough. And that's, again, that goes back to each soil is different, all the specifications for that is different, and the design, ultimately the foundation design is different for each location. All right, so we have Antonio over here. He's tying in the vertical bar, that number 4 bar. You'll notice he'll get it located, so they've got location marks up all of the vertical. So that horizontal bar, he'll hit its location. And then you'll see him use the gun and tie all of that in at the location specified by the structural engineer. What we have here, just to take a closer look at the actual structure and bar itself, but what we have is 2 inches from the outside of the foundation wall. The overall thickness of the foundation is 8 inches. 2 inches from that, we have our structure, our grid, our mat layout here. So you can see that go up, come in. So overall, we're on 16-inch centers. So one that's 2 inches away from the outside, and another 16 inches spacing that is 2 inches away from the inside. And then our verticals are 16-inch center going up all the way. We'll then do that again, as you can see here on the inside. We'll start with that number 4 bar on number 4 bar, 2 inches from the inside, start here, and then go 16-inch centers all the rest of the way up there. And that will make up the actual mat and structure of the stem wall or foundation wall. All right, guys, so that was just the basement portion of this foundation. We have a lot more foundation to go. We'll bring you back out when we start this upper crawl space area that you see here off to the side. So we'll continue with foundation for the next little while, both foundation and backfill, and then right after that we'll start rough-in plumbing inside the slab. So we're excited to have you along with us. We hope that you follow along. Don't forget to like and subscribe. Tell your friends about us. We look forward to seeing you again.